I'm a game changer. I'm a risk taker. I don't hide from the battle. The battle hides from.
Hello everyone, I am Heng Teng Yi from Singapore. I am participating in the Rescue FirstSteps U19 category. I've been doing robotics competitively for about 1.5 years now as part of my school's robotics club. In terms of RoboCup events, I've taken part in the RoboCup Singapore Open and the main RoboCup event in Sydney last year in the junior soccer lightweight category. My main role was working on hardware design, so designing, wiring and assembling the robots. On to my learning experience. CoSpace Robot was basically my first time doing search problems since I mainly did hardware beforehand. In addition, to implement more complex strategies, I also had to learn how to program the robot in C, which was a language I had only dabbled in before. I am most interested in SG5114's video for Rescue U19 from the first sharing session. This video is not in my category, but I am planning to take part in the regular Rescue U19 category in the upcoming virtual RoboCup Asia Pacific event. I would like to learn more about how he processed the image of the map and used it to improve his robot's pathfinding, since such strategies can be applied to any map rather than being specific to a certain map, so it seems useful when preparing for future attempts at CoSpace Rescue. To share my knowledge on robotics and AI with others, well, I'm still learning, but I post my robotics projects on my GitHub, although not very well documented, and of course I help my fellow clubmates and juniors when preparing for future competitions such as this one. Now for my strategy, I will start with square targeting. In my strategy, the robot has squares it wants to travel to, and by squares I mean one of the 3x3 coordinates. But how does it know how to travel there? Firstly, there is a target angle that we want the robot to move forward at. For example, if we want the robot to move one square to the left, then we will want the compass to read 90 degrees. Using the compass reading and proportional control, the steering rate of the robot is adjusted to rotate the robot towards this target angle. But when it is moving towards the square, we also want to make sure it does not run into walls and obstacles. To handle this, there is a separate steering rate for wall avoidance when any of the ultrasonic sensors have a reading below 25 to rotate the robot out of harm's way. And the two steering rates are merged such that the lower the ultrasonic readings, the higher the steering rate for wall avoidance and lower the steering rate for square targeting. Moving on to some of the robot's basic functions, there is detecting objects to pick them up and detecting the deposit zone to deposit them. The simplest way to detect objects and deposits is to check if the color code of the landmark matches the color sensor readings. But to increase sensitivity, the code actually checks if the readings are just close enough to the color codes, with a leeway of around ± 25. This lets the robot get more objects faster. In addition, to avoid losing objects, there is trap avoidance. To prevent the robot from running into the traps, it slows down to 80% speed when it is facing them, so the robot can see the warning in time before running into the trap. Once it sees the warning, it will reverse and rotate out of the way. I will go into the movement strategy now, one key feature of which is fluid movement. So one common strategy is to use the markers and position coordinates to code a fixed path for the robot. For example, it could travel to the top left square, then the middle left square, then the center square, and deposit at the top. This approach is limited in that the objects spawn in random areas, but the robot usually covers a small area due to its fixed path and retreads previously covered ground as well. Hence, to cover more area and collect more objects, the robot does not follow a fixed path and travels wherever it wants to, turning only to avoid walls or target specific colors. This brings me to another main part of the strategy, which is for the robot to target specific squares with specific colors to get 2 objects of each color and gain 180 bonus points per deposit. So for example, if the robot has 2 red and 2 black objects, it only needs cyan objects, so it travels to the center and bottom right squares since those are where the cyan objects spawn, and avoids the rest. And once it's in those squares, it resumes fluid movement. Other than getting combos, the robot also avoids traveling to the bottom squares. The bottom left square has no object spawning in it, and all the bottom squares are very close to traps. Hence, the robot immediately turns around when in the bottom left square, and does not actively target the other 2 squares, although it will stay in those squares if it travels into them by chance, since they still spawn objects. In addition, since the bottom is dangerous now, the robot deposits at the top middle square. So the entire strategy is this loop of collecting 2 objects of each color and depositing at the top. In terms of problems I faced, the main issue was mainly dealing with syntax errors in C, which are minor enough not to show up when compiling, but can cause the code to malfunction. For example, multiplying an integer and a float gives an integer result, and using one equal sign instead of 2 equal signs can give incorrect results in if statements. If you've done C, you'll probably recognize these issues, and they are quite minor, but since my program was rather long, it sometimes took a lot of time to catch those bugs in the code. And throughout the challenge, my main method to improve my scores was to find ways to use the map to my advantage without coding a fixed path. So that's why my robot strategy made use of the traps positions, and where each color would spawn, and also the locations of the obstacles. Another thing to note is how useful the 180 point bonus is. If the robot is able to get 2 objects of each color and deposit, it could score higher even if the opponent collected much more objects. So that's why my strategy always aimed for the bonus. Okay, that's it. Thank you for listening.